in these days, back about 10 years ago, I never had to teach this. But now, since you guys are working with the computerized software, a lot of times when you're doing your homework, right? So graphing becomes a little more interactive right here. But I gotta show you guys to make sure you understand what you're doing. So let me bring back that trig function that you guys sketched on your own with papers and pencil earlier. 2 times sine of minus 3, right? So we grabbed that by hand earlier, right? So the skill doing that by hand is good, and you've learned that. But now when you're doing this with a computer, especially the kind of assignments you guys will be doing, so I gotta let you guys know a little bit. So this is the graphing space similar to the paper you guys have, right? You guys see that when you're working on these problems here, at the bottom you are provided with 2 separate tools. See what I'm saying now? One tool is, the idea is the tool relies on 2 points. So you see that they're all waving signs, right? See what I'm saying now? These are the 2 tools that meant for you to create the graph for sine and the graph for cosine. So that tool on the right hand side right here is meant for cosine, because you see the way how those 2 points is. See, when you think about that point in the center, goes right through the center point, and so if you go from that point to the upside and that down, right, it's forming this graph of a sine like this. You know what I mean? And then the other tools right here, the 2 handle points are right at the peak of your graph, which is more suitable for the cosine graph. See what I'm saying now? Okay. So the function that we have right here, that was actually one example that I purposely brought up from this computerized version. Right? And then I want you guys to do the graphing on your own with papers, and then let's see how we can do this, right? Using the machine, using the software program right there. That's eventually you guys are gonna have similar problem when you doing your assignments. So the function is a sine. You guys follow it? Right? So it's better that we choose this option right here, like because I explained that earlier. Right? This graphing feature right here, this tool is better for graphing that. So the center line, see, read back on your record. Read back on the record. Where's the center line for this graph? Right? Y equals -3, so the center line gotta be down here. See what I'm saying now? Right? The center line, and where's the starting point? -π/2, so we start here, right? So with that tool, here's how I see it. See, when I put a dot right there, right on -3, right? Put a click, that's the first handle point, like similar to that one. See what I'm saying now? And once you click on that, see, as you move your pencil tips away, you see how the second handle point comes out and it produces the peak with that of your graph. So see, the idea is you want to make sure that the peak happens. So from starting point to the ending point is right here at π/2, right? That's your total window right here. But you want the first peak to land at the first quarter and about amplitude 2 up. See what I'm saying there? Right. So in this way right here, in the way how I'm seeing, and then you click, make one click, and then that point is going to land right there. See? So first point is here, beginning of your graph, right? First peak happens as a quarter point, starting and ending point right here. So of course, the machine has to give you the whole complete graph, but what you're looking at is only one portion. So as long as you can complete one basic unit, so that the rest of the graph will come out correctly. See what I'm saying, huh? Right? So now you can see that. See? Starting point, right? Ending point just agrees perfectly with your graph earlier, right? And then the amplitude 1, 2. Right? Amplitude 2, and the graph goes like that, just agree with that. So now if you restrict your attention to just within that, then the first peak, right, the first high point of the wave that happens right at the quarter, right, and then halfway crossing through the center point, and then third quarter gives the bottom point. See what I'm saying now? And that's your graph. See what I mean? And once you got your graph in and double check with your drawing, right? Double check with your drawing, then you can just go ahead and hit submit, similar to the way how you run your homework problem. Right? Hit submit, right, and double check it. See what I mean? So I highly recommend working on this kind of assignment right here, especially when it comes to this kind of problem where you have to plot it with a machine. You can work on a PC right there, either a laptop or a computer. You know what I'm saying? Don't use that on a mobile phone or some kind of mobile devices. The touch feature is not working so well with these things right here. Right? So you definitely want to be on a laptop or on something that has a mouse click for that. Sounds good with me on that? Okay. And so here's our graph right here. And I didn't ask you guys to do this earlier, but now we can quickly work on that together right here. Right? With the function we have, it's a -2, right? And then there's a cosine, and then in parentheses is a theta plus π/4, right? And then plus 3. So that's your function right there. And we want to sketch that here by hand, and we want to use the sketching tool to get the work done. So as easy as it can be, center line. First, if we narrow it down, center line for this graph. Y equals, that number is responsible for that, right? Y equals positive 3. Good. And then we count the amplitude. Next thing to track down, right? Amplitude for your function will always be absolute value of your coefficient in front of your trig function, right? So that coefficient is -2, but then the absolute value comes down to, that's your amplitude. Right? So from the center out, it's going to go, 2 units up and 2 units down, or 2 units away from the center line vertically. The period this time, right? The period this time. Who can tell me how big that period is? Always 2 pi and divide by some number, right? What's that number we divide by? What's the beta coefficient? 1. Yeah. So absolute value of positive 1, right? That gives me the complete. It's 2 pi. Sounds good? And so this function here looks pretty in factor form already because it's simply just coefficient 1, so there's nothing to factor, right? So you can purposely see this as theta minus negative pi over 4. See what I mean? That shows your starting point. So the starting point here will be at x or theta, whatever, right? Theta, I change variables, and here theta starting at pi over 4, negative pi over 4 and x. And then the ending point now, rule of thumb, right? It's going to be starting point negative pi over 4, but we added with the 2 pi unit there, right? Just 2 pi. That, we made that there. So what's the final mass right there for that? Minus pi over 4 plus 2 pi. Okay, 7 pi over 4, right? Sounds good. So, and the graph right here, there's a negative sign in front of your coefficient, right? I mean, there's a negative sign, coefficient, and the negative coefficient multiplied with the cosine. So be ready that you're from the center line right here, start and halfway, first quarter, third quarter, right? Your cosine this time is going to be the flipped over version. It goes like that. See what I mean? It goes like that, right? Because of that negative sign, making it the mirror reflection through the horizontal, the center line. It's vertically reflected. So that's what's expected. And so in that way, here's how I'm seeing it. You can call that the start right here at so on the center line. So the x-axis maybe, right? The x-axis may be down here, right? Whatever. So I'm a little off scale right there, but it's okay. Amplitude 2. There we go. Just right about there. See what I mean? Center line, the x-axis. That point right here. Actually, I'm live already. So the y-axis is kind of like somewhere here. That's how we see it. But I'm just illustrating the idea that now when we're bringing that on the picture, so that's something to expect, right? On the picture right here, here's how we do it. This time it's better that we choose this tool right here, right? This left tool right there for drawing a cosine. Okay. Now the center line is right here. You guys would be there? Okay, that's where the center line is. So right on that center line, we have to locate the starting point. But starting point is a negative pi over 4, right? Which is about halfway between 0 and negative pi over 2, halfway. So these things right here are programmed to automatically snap into those smart points. So we need halfway between 0 and negative pi over 2. It's going to snap immediately. So on that center line right here, the first point is at it's down at 2 down, right? So negative 2. So it's 2 down. So it's going to be kind of like that. See what I mean? Right? It snaps right exactly halfway. And then this time it's going to swing out just like that. See what I mean? But you're going to have to identify, so is this the right point? Nope. We need to move it out a little further because you see your ending point right here. That ending point has to land at 7 pi over 4. So that's right there, about right. See what I mean? Right, that other peak right there. So the first peak happens right there. Okay. So Now we can just click on that. Oops, I just misplaced that. Right there. Right. Click on that. That's our graphic there. So this portion right here is the graphic. We hit submit. Are you following my explanation of how you run that thing with them? Yes, the confusing part is that it's giving you the whole complete graph, but what you need to pay attention to is simply just that portion inside of the window that you drew on your hand sketch version of that. See what I mean? And then use that, use probably that tool where you go. So the rule of thumb now is that, so the space from here to here, right, has to be from one peak to another peak. Okay? So make sure that peak lands right at halfway between your, because starting point is here, ending point is at 7502, right? So you adjust that so that this ending point falls right at 7502. See what I mean? And then make sure you drag it up and down so that it leaves enough of the space of 2, right, for you the amplitude consistent without buffer. See what I mean? That's how you work on that with machine. Right? That's the idea. All right.